So I think next problem will be easy only because it's not a real number set. So this and all I think you have solved it. Right. Show that the relation R in the set 1, 2, 3 given by R is equal to 1, 2, and 2, 1 is symmetric, but so obviously it is symmetric. It is symmetric, but not reflexive because you don't have what is missing. 1, 1, 2, 2, and 3, 3. All neither of them are there. And it is not transitive because 1, 2 is there, 2, 1 is there. What is missing? 1, 1 is missing for it to become a transitive. It is not leading to anything. Okay. Next. Show that the relation R in the set A of all books in a library of a college given by R is equal to X, Y such that X and Y have the same number of pages. It's an equivalence relation. For reflexive, obviously it is possible. What will you write? Reflexive X, X belongs to R. Why? Because the book has equal number of pages as itself. What about symmetric? You will take, if I say X, Y belongs to R, can I conclude that Y, X belongs to R?
Yes, sir.
What about transitive? X, Y belongs to R, Y, Z belongs to R, then what can we conclude?
X, Z also belongs.
Here it is same number because of equal to, you're not worried. Right. What about this one? So as I told you, first solve this part we'll do it later. Show that the relation R in the set A given by 1, 2, 3, 4, 5. You need to use the ordered pairs A, B such that modulus of A minus B is an even. Reflexive. Yes. So what will you get? A belongs to R? Yes. What about symmetric? A, B belongs to R. Does it imply that B, A also belongs to R? Because this will be even. This will also be even. What about transitive? A, B belongs to R. B, C belongs to R. Then what about A, C? Belongs to R. See, I'll just give you another thought process of how to, maybe you can write it like this. What is the general notation of an even number? 2x or 2n, right? So, for a number, for the difference of two numbers to be even, how are the numbers supposed to be? Both the numbers are either supposed to be odd or even, right? Suppose I take them to be something like this. A is equal to 2n, right? If I take, for example, B is equal to 2n plus 2, right? Or else I can take 2n plus 4, 2n plus 6, 2n plus 8, anything, right? Then what will C be? Can I write it as 2n plus 6, for instance? It's my wish, right? What about A minus B? 2. It's an even number. What about B minus C? 4. What about A minus C? Right. In a similar way, if at all you take A to be an odd number, see, I'm not saying you need to write it like this, only a thought process. Okay. So A is equal to, if I take them to be odd number, how can I take them? For an even number, you add a 1 or a subtract 1. What will it be? Odd number. So 2n plus 1. B is 2n plus some number 5. C is 2n plus. So if you do and see, you will still get the even number. Are you getting it? So 2n gets cancelled. You will have 4. Here what will you have? Here you will have 2, and here you will have 6. It's still the number. Sorry, even number. Okay. So you can think of this kind of a procedure. Maybe instead of this set, had they given you some Z X. Here it is simple, no? 1, 2, 3, 4, 5. Right. Next. Answer. What is it? Show that each of the relation in set A where set A contains what elements? 0 to given by R is equal to A comma B such that modulus of A minus B is a multiple of 4. Same logic. So multiple of 4 means what will you write? How will you take the number as? A is equal to 4n. Right? You can take the numbers like that. Okay. So A comma A is possible. Yes, it belongs to R. A comma B is possible. Right. What about B comma A? So if this is possible, this is also possible. A comma B belongs to R. B comma C belongs to R. Then what about A comma C?
It also belongs to.
Does it? Yes. So R is equal to A comma B such that A is equal to B. Symmetrical. Everything. Sorry, reflexive. How? A comma A because A is equal to A. What about symmetric? A comma B belongs to R. Then B comma A also belongs to R. What about transitive? A comma B.
A comma B belongs to R.
B comma C belongs
And B
to R.
comma C belongs to R. And A comma C also belongs to.
Belongs to R. Right. So it's simple. Tenth one. I think this is the last problem I asked you to solve. Like, what about this? Give an example of a relation which is symmetric but not reflexive, not constant. You need to think of it. R is equal to 1 comma 2. But what is the set you are considering? What is the set? What set are you taking? Let's give me a set. A is equal to 1, 2, 3. Sorry, 1, 2, 3. Okay. You want to do, so for the first one, you need to frame a relation which is symmetric, but so what will you take? So 1 comma 2 is there. 2 comma 1 only, no? Because you need to take it to the. It's not reflexive, not transitive. What about transitive but not reflexive? 2. R is equal to x comma y. Y is x plus. Okay. See, if at all you don't get idea, look at the previous questions wherever it did take it. So that you can take it fast. It should be less than 5. This is not working out. Okay. X is less than 5. Is it transitive? Sure. So which set are you taking? What are the set you are doing? But I took 1, 2, 3 there. No? Natural number. Okay, you want me to take them to the natural number set. Okay. So reflexive obviously it will not happen. Why? So 1 comma 1 does not belong to R. It's not possible. So we should prove that it is not reflexive. Okay. What about symmetric? Not symmetric. But how did you prove that it is transitive? What numbers will you take to prove it transitive? 1, 2 belongs to R. You get 2 quota. If you put 2 here, you will get 6. You're wrong. Then give me some other relation. I told you can look at the previous problems, take an idea from there. X is less than 1. Okay, 1 comma 2. So 1 is less than 2. What about the other number? Okay, but 1 comma 3 will work out. Then you need to take this. Oh, it is transitive. Huh? Okay. So 1 comma 3 belongs. But here the question is not about you defining this condition. It is about how you take this set to be. By the real number set will it work? Real number work out. I told you R is equal to X comma Y. You told X is less than Y. What are those numbers X and Y? Are they real numbers or the integers? Are they natural? Okay. Make a note of it. Tell me the next class. Now you need not break your head. So if we take real number, is it working? This condition still working, whatever. Okay. Next. Tell me a relation which is reflexive and symmetric but not transitive. Instead of you framing that, why can't you tell me the order first? So that it is easy. You can take anything, you need not go too complicated. So just take a set with smaller numbers. Take A to B. How do you want to take them? Shall I take it to be 1, 2, 3? Okay. For the relation R, I take it is reflexive. Did we prove this condition? And symmetric is what they are saying. So for it to be symmetric, what should I take? If I take 1, 2, 2, 1, no, then I have 1, 1, then it will become transitive also. 1, 3, or you can take 2, 3, 3, 1. Sorry, 2, 3, but it should not be transitive. Then it will not be symmetric. Sir, any other? No. However, you took take will get better. And see, if I take 2, 3, 3, 2, I'll have 2, 2. Transitive. So for that to get avoided, make the set smaller. No. Take 1, 2. Only 2 elements set. Strike this off. There's not there. So 1, 1, 2, 2 makes it reflexive. 1, 2, 2, 1 makes it. Oh, you again got this. Again 1, 1 is. If you take 1, 1, how do you prove the symmetry? That's not good. So think of another number. Think no. So what is the answer? Can you define a relation then? R is equal to x comma y such that what do you want to take it as? Like what shape? What it is? No, this will be 1 comma 1, 2 comma 2. That can frame what will be the equation. You can take x is equal to y. Yes. Then you will have only this thing. There, yeah. Now you can see. Okay, because we don't want this transitive to come. Whenever you take this 1 comma 2, 2 comma 1, no, by default, this transitive will come into picture. So you can take like this, you can take any number of terms you want. 1, 2, 3, whatever you take, you should have equal number of coordinates. 1, 1, 2, 2, 3. So shall we do the next one? Reflexive and transitive, but not symmetric. That we already did. You guys tell me. That's the condition I'm imposing. That's the relation I'm imparting. I am framing, I am saying A is equal to 1, 3, and the relation I am defining is x comma y such that x is equal to y. Is this relation is symmetric one or not? That's what I put it. 1 comma 1, 2 comma 2, 3 comma 3 are the reflexive. 1 comma 1 and 2 comma 2, 3 comma 3, it is becoming symmetric also. Because what should we avoid for it not to be transitive? If I take 1 comma 2 and 2 comma 1, for example, if I take that condition for symmetric, then what will I get? I get 1 comma 1 also, which will become transitive. I don't want the transitive to come. That is why we have imposed this kind of condition. Okay, so what is the time? What is the time? 6:05. Okay. So the next two, will you guys try it? How many more problems are there? 6 more, right? Right. Can you try it before the next class? Right. So during the weekend, sit and complete that, and we'll have a discussion, and we'll go to the functions part. And I gave you 2 more tasks. What is it? In that problem, this one. You check what will happen if you change the natural numbers set to real numbers and integers. And the other one is that problem where we were trying with fractions. No, try a different set of. I want different set of numbers. So which problem is that? Problem number? So for 5th one and 10th second one. 5th one and 10th second one, you need to find out the different values and